In this video tutorial, we are going to build the diagram application that you see on your screen. This app is written entirely in JavaScript and uses the MindFusion diagramming library for JavaScript. Every part of this diagram is a diagram item, a shape, a table, or a link. Text can be edited interactively. You can create diagram items with drag and drop. You can change the background color of any selected diagram shape. There is a button to export the current diagram as a JSON file and download it. You can load diagrams from a JSON file through the file picker. The final version of this project includes a file with a DevOps chart in earth colors and loads a predefined diagram. We are going to build this application from scratch. We have a lot of ground to cover, so let's get started. We go to the MindFusion website and navigate to the page for the JavaScript diagram. You can download the trial version, which includes samples for various platforms, or you can install only the library from npm. If you download the trial version, you will see that the archive contains the scripts used by the components. Let's copy those from the folder with JavaScript samples. As mentioned earlier, we start out project from scratch, e.g. with an empty folder. Once we have the scripts, let's open the project folder with Visual Studio so we can use its feature to start a web server when viewing web pages. Now let's create the web page for the application. We add the code for a completely empty HTML page and customize the global font. Time to add references to the diagramming scripts we are going to use. We don't add a reference to every file in the scripts folder. We won't need all of them for now. If we get back to the final application, you see that it has a list with the shapes to the left. This is the diagram's node list view control. Just like the diagram view, the node list view needs a canvas element to render itself onto, so we add one to our web page. Then we add another canvas element, bigger than the first one, for the diagram. For now, this is all we need to add to the web page. So, time to start writing some JavaScript code. We add an empty JS file to our application and add a reference to it in the web page. First, we add some name mappings to make our code easier to read. This is not mandatory. You can reference the classes with their full name. We also declare two global variables for the node list and the diagram. We create the diagram object, and we also create a diagram view, which will render the diagram. We also create a node list object. Note that we will need a reference to the canvas elements from the web page. That is why we have provided them with an ID. So, in theory, now we should have a web page that offers basic diagramming capabilities. Let's see that. Yes, here is the diagram area. So far, so good. Let's add now some customization to our diagram and the diagram view. We use a few of the numerous properties of these two classes to specify the behavior of the diagram. To allow in-place edit of diagram objects, which is the reason users can type in text and others. If you wonder how you'd find information about these properties, you can navigate to the online documentation. Each API member of the JavaScript diagram control is listed. We add some styling to our diagram through styles and themes. They specify all aspects of the appearance of the diagram: fonts, brushes, strokes, pens. Here is how you specify the class on which the style should be applied. The styles are added to a theme, and the theme is then assigned to the diagram. We also change the back brush for the diagram, so we can see it on the page and make the links dynamic, e.g., they will automatically adjust their segments, start and end points when dragged with the mouse, or when the position of the nodes they connect changes. Let's run again our sample to check the results so far. You can clearly see now the diagram area. When you have a link and you move it, or move its adjacent nodes, you can notice how the link segments change position. That's what the dynamic links property does. Time to start filling the node list. Let's start with the arc shape. This is a custom shape, and we are going to use the Shape Creator tool to design this shape. The Shape Designer is available as a desktop application, but it is also available as a web tool from the MindFusion's website. You can drop various segment types on the segments of the initial rectangle, drag their control points to adjust the shape, or delete redundant segments. When you are ready, you can export the shape as a file. In essence, this file is an XML file that describes the diagram figure in an SVG-like manner. You can open it and edit the coordinates and lengths. We move the file to the directory of our project and create an XML copy of it. We will load the XML file. We create a new shape library instance, which is the class that takes care of loading and storing custom diagram shapes, and not only custom shapes. You can read about it in the online documentation. In the onLibraryLoad method, we read the shapes that were loaded from the XML file and check for the quarter arc shape. If it has been loaded correctly, we add it to the node list view. We also change the default shape of the diagram to be ellipse. We identify it by its name because this is a predefined shape. The predefined shapes with their identifiers are listed in the online documentation. Let's run the sample. Yes, we can see our custom shape now, and we can drag and drop it on the diagram area. We add now the images that are going to be used by the oval nodes that will represent the process stages. Let's create an array that contains them. Now we will add a method that creates shape nodes that have each one of those images as a background. We add a transparent node that renders text in a larger font. We also cycle through all members of the stages array and create nodes that have as a background one of the PNG images. We specify the image with the image location property. If we run the sample now, we can see the image nodes and the text node in the node list. Let's increase the size of the nodes in the node list view. There is also something else. The nodes get their stroke from the theme, and it is dark orange. Let's change it to dark gray. The other type of label in the diagram is represented by a custom table node. The table node has 2 rows and 2 columns. The first cell on the first row is narrow and holds the number. The other cell is for the description text. The second row is very thin and actually represents the underline. Once we drop this table node, we can see that it is too long. We want its height to be exactly enough to contain the label and the underscore. Let's fix that. We will handle the node created event that is raised whenever a node is added to the diagram. You can check the list with events in the documentation. The event data gives us information about the node that was created. So, if we detect that this is the table node with the double labels, we give it appropriate size, so it fits the text and the underscore well. How do we recognize what kind of node is being created? An easy way to do it is through the tag property. The tag stores any information you choose, and there we store a string that tells us what is the type of the node. Let's move to customizing links now. Links have their own link created event, where we specify that the head and the base shape of the newly created links are going to be null. When we are drawing links though, the base and the head shapes are still visible. in order to stop that, we need to handle the link creating event as well. You might have noticed that nodes can be rotated now. This is because we have set the enabled handles property of newly created nodes to all, which means that users will see handlers not only to resize, but also to rotate the node. It's time to extend the web page. Let's add first the color picker that allows us to change the fill of a diagram shape. When you specify that the type of an HTML input element is color, you get automatically a color picker control to edit the currently selected color. We give an ID to this input element and add a new variable in the code behind file, background color. We will store there the currently selected color. We are going to get the DOM element for the color input control and set its value to the value of the background color variable. We will also handle two events for it, input and change. We will use the same method for both of them. Let's test the code now. Yes, it works. Just don't forget that in order to change the background of a diagram item, you need to select it. We add a button that will download the current diagram into a JSON file. When clicked, the download method is called. The download method creates a file called diagram.json and sets it as a URL to a link that is dynamically created. Then, the link is clicked programmatically so that a download is triggered. Let's test the button. Here is the downloaded file. Its contents look correct, but there is one way to check this. We need to add the possibility to load files to our web page. We add a file selector with a filter for JSON files to the web page. We handled the change event for the file selector and check if a file was selected. If so, we read it and to try to load the diagram from it, calling the FromJSON method. And this seems to work quite well. We can load JSON files that we have previously saved with the application. Now there is one thing left to do. We need to add a button that clears the diagram area, so we can quickly start to create new diagrams. We add a standard button, whose click event triggers a method. The method simply calls the clearAll method of the diagram. It works well, so our sample is ready. We have just finished building a complex web application in JavaScript that allows users to build process flow or operational diagrams of any type. You can download the full source code from the link in the video description. Thank you for watching, and thank you for your interest in MindFusion developer tools.